This is the transfer function for an actuator. And the actuator is shown in the S domain. It's as a first order system. That is, as a first order linear differential equation. Now these constants are important. The block diagram is shown here, where the actuator is normally inserted in the forward part of the feedback loop, as shown here. Its output of the actuator drives the aircraft as an elevator, aileron, or some control surface. The input of the actuator normally comes from the forward loop, and often it's an error signal from a feedback loop. But we're concerned today with only the response of the actuator itself as part of the feedback system. Now the parameters in the transfer function are important. The K0 subscript means the steady state value of the step response of the transfer function is given by the final value theorem. So if you let s goes to 0 in the transfer function, you'll end up with K0, because the unit step function, the Laplace transform of a step, is 1 over s. So these two terms will cancel each other. And just if you let s go to 0 in the actuator transfer function, you'll end up with K0. Ts is the time constant, and that's how fast the system will get to 63% of its final value, or 1 over e, where e is the natural log. So if the time constant is large, suppose we had value of 2 over 5s plus 1. The time constant of 5 seconds would mean it would take 5 seconds following a step input. 5 seconds following a step input for the output of a step response to get to 63% of its final value. The final value, of course, would be K0, which is in this case 2.